All right, now you have a correct design, which is essentially, all right, all the features required from your system have been supported or implemented by your design, realized by your design. Okay? Now if you're not breaking any of the non-functional requirement like timing, safety, and so forth, then you have a correct design. All right? You may have a bad implementation, bad design for the system, right? For instance, if you have doing a search, if you implement your search with a linked list, all right, your design with a linked list as data structure, yeah, search is not going to be a very easy process. You have to go through a linked list. Essentially, you have to, in the worst case, you always have to go through every element in your linked list, right? You may say, fine, that's okay. It's linear. It's not too bad, right? But when the number of elements in your list is long, it can take a lot of time. All right. So in that case, a better design may be a binary search tree, right? Say, oh, guess what? I'm going to cut the search time to log in now. All right? That's a better design. But can you say that, oh, okay, your design in terms of linked list is totally wrong? No. I mean, if you don't have a runtime requirement, guess what? My linked list may actually work. Just slow, right? You cannot claim that's the incorrect design if I don't require certain time bound, right? But binary search tree may be a better design, give you better performance, right? So in terms of inheritance, the idea is pretty straightforward. You have sets of objects. You have bound class and stock class. Okay, that's basically the two major investment vehicle in Wall Street, right? What is a stock? What is a stock?
Part ownership of company.
Part ownership of company, right? What is bond? What is bond? I mean, you're paying for it, right? If you earn money, you pay tax, right? If you or your parents, your relative own a real estate, I mean, basically you have a house to live in, or even you're renting a house, renting an apartment, you're actually paying for bond. Why is our public school have all these bond measures and all the time? Whenever we have elections, we have all the bond. Oh, you should say yes on the bond 93. Man, you should definitely say yes. What is bond? Bond essentially is actually we're borrowing money from the bank. Your school district is borrowing money from the bank. PSU is borrowing money from the bank, right? A bond program is, okay, guess what? I'm going to borrow this money from bank up front. I got $10 million from Wells Fargo to finance repair of Lincoln High School. Okay? Then basically Wells Fargo gave us this loan, say $10 million, and then we have to pay them back. Who are going to pay them back? You guys. If you live in Multnomah County, you are essentially financing Lincoln High School. If you live in Beaverton, you're basically financing bond that's paid for repair or improvement of all the schools in the Beaverton School District. Essentially, we pay tax. The tax revenue will be collected and paid to Wells Fargo with the interest. Okay, so certainly Wells Fargo eventually will probably get $15 million back over the year because we actually pay the bond, pay the interest. So essentially, to investors, which is Wells Fargo. Actually, Wells Fargo, on behalf of their customers, in some cases, it's all investment. All right. So to them, they say, oh, guess what? These two things have something in common. For instance, they have value. They probably have owner of this. Owner so who owns those stock and who owns this bond, right? So all this information can actually be aggregated together. This is essentially a design syntactic sugar. Is this totally necessary for us to implement the computer program? No. The thing it does for us is to improve our design and coding efficiency. I mean, for the program we are using right now, the PowerPoint, is it possible to write this all in assembly language? Theoretically, yes. You put enough people on it, yes. However, was it written in assembly language? No. Right? So essentially here, the same thing. You don't have to use inheritance. You can still implement the same program. I mean, we survived years without inheritance in C. C doesn't have object, doesn't have classes, doesn't have inheritance, but we did all the wonderful things, Linux operating system, all the databases, majority of the switches in our backbone internet, all in C programming language. Okay? So why is it important for us to learn this? Because by using C++ inheritance, we may improve our coding and design efficiency. So that, in this case, it's a matter of efficiency, not correct or incorrect. You can still do the same thing with C language, no problem. All right, association. Another idea is association, which is say, okay, this is the case when they have some relationship. Okay, they have a relationship. They talk to each other. Okay, essentially with this kind of relationship, association means, okay, it's possible for radiologists to send a message to a lawyer. Certainly the other way around is also possible, but this link here, just say, you're just saying on your class diagram, it is possible for radiologists to send a message to a lawyer. That's it. That is essentially your information. Say a radiologist may send a consult message to lawyer to ask for whether something is legal or not. Okay? Then this real implementation are going to be in your sequence diagram, your collaboration diagram, and eventually your state charts and so forth, to have this, really there's the message going from radiologist to lawyer. Right? The lawyer may just say, so provide an interface for people to consult. I mean, many lawyers online now, I mean, they do the same thing. That's why, so artificial intelligence actually going to play a bigger part in reduce the number of lawyers and law clerks. Right? Many things we consult lawyer about, many questions we have, actually can be relatively easily answered by artificial intelligence assistant, maybe more accurate than a human assistant, right? Many of the documents currently being prepared by a law clerk, all right, or secretaries and so forth, can actually be prepared automatically with our AI programs, right? Certainly, eventually, to assign blames, who will take the final responsibility of, okay, give the seal of proof, we still need human being. The lawyers finally will review the document and make sure it is up to them. They agree to it. They agree to things that AI generated. They have to review that. But the preparation process will probably be automated quite a bit. This is actually happening, right? I mean, think about it. The way the tax prep industry is going, the same thing, right? Years ago, without computer program, without program like tax cut, I mean, all these tax software or this free software, either you go through the booklet, you print out, you get the form, you actually go get a physical form from somewhere, I mean from government, and you fill out these forms manually, then mail them out. If you need the information, need to go get a booklet for tax regulation, and you check all these things. Now, or you say, oh, I'm willing to pay the money for a tax preparer. I just give all the document to that person, and he or she will fill out the paper form for me. Now it's actually changing, right? You can still go to your accountant and your tax preparer and say, okay, here are all my documentation. You fill out the tax for us. Or you can buy a piece of software like HRM Block, right? And just file your tax yourself, right? In fact, your tax preparer, they are doing the same. They are essentially just using a more powerful version of HRM Block and fill the tax for you. Okay, so in that case, you can see that this is automation. Okay, this is automation. The amount of work that the computer program is saving you from going through all these law regulations and tax laws, so that you don't have to check them. They give you a questionnaire, you go through. Okay. All right. So also you can record transactions, right? If the radiologist consults the lawyer one time, there's a transaction record. Well, why is that important? Why is that important? I mean, you go to talk to the lawyer, yeah. You talk to the lawyer. Why is it important to keep record? This is to keep record. This diagram, you can see that if you look at this, there's no real say, oh, this is something we invented. No, we just map this from real world into computer program. That's all we do, right? Why is it important for us to record the transaction by introducing another class? Here, the idea is, anytime your radiologist talk to his lawyer, actually there is a record, a class, an instance of this class created to record that transaction. Why is that important? And do you actually generate this kind of transaction yourself? Kevin, what do you think? Could you actually generate this kind of transaction? Could you? You guys, could you actually generate those transactions? When? This is just an example. Say, oh, certainly nobody here is a radiologist, I'm pretty sure, but why similar things happen to us all the time? That's why I'm saying here in software engineering, we didn't invent this. This is actually happened in years and years, I mean decades or even millenniums and thousands of years in practice. Just that what we know is, okay, this is how this should map to a computer program. That's all. When this happens to you guys, when it's necessary for you to interact with somebody, and that interaction need to be recorded? When?
Buy something, maybe get a receipt.
Exactly. So if you go to Amazon.com to buy something, you actually go to Amazon.com, your transaction is recorded. Why that's important? Why that is important? What if you don't have that record?
Yeah, if your package doesn't come, you don't have proof.
Yeah, you have no proof you actually purchased something, right? Amazon need to keep track of you actually come to them, right? If they got audited or something, they can say, okay, guess what? Yes, you had this transaction. We did send out the package. This is the UPS tracking information, right? So this is record keeping. Record keeping. I mean, we are all doing record keeping. We all know the downside of not keeping record, right? Then basically we have no proof or we lost information. So that's why, okay, all the record keeping happening in practice is something we can automate with computer program, right? You may say, wow, this is so boring, right? This is so boring. Guess what? IMDAN.com is in the business of keeping this record, facilitating this kind of transaction and keeping this record. That's everything it does. And you guys are doing that in my class project. Whenever I send you a message, that message needs to be kept. So I can go back to retrieve that message. Okay? So that if that message happened, should be retrievable. Okay? All right. So notes, we don't need to say too much. This is just your comments in your code. Use case diagram. We have spent quite a bit of time on this. This is the model of interaction between external users. That is the emphasis of this item, right? It's an external user of the software product and with the product. You are examining the product, the software program, from outside. From outside. Okay? That is why it's called use case diagram. How you use the system. How somebody else use the system. That somebody else can be a computer program, right? Literally, if you actually, for your class project, you can actually define two systems, right? One is your client system, the other is a server system, right? That actually happened in practice. That is what happened. I mean, you can go to imdan.com on your phone using imdan app, right? You can also go to the same place on browser to retrieve the same information, right? So your server and your client program are actually designed to be separate programs. Okay? So in that case, you could have two systems in your project. Or, you want to be simple, you can have only one system in your project. Which design is better? I don't know. In your case, maybe the one system design is better because it simplifies things. Right? But in practice, actually, more likely than not, it's going to be two systems. Okay? So basically, you're looking at your software product from outside. Outside. A user, actor, can be a human being, can also be a computer program. Just an abstraction. Right? It can be a user, can be a computer program, can also be a human being. Or you can have stereotypes, basically say you can define something, something, this is just for you to, okay, you can actually, this is syntactic sugar again, to make your representation to be more meaningful in the sense that, okay, you can say, okay, actually preparing form, I'll have the capability of printing these forms. But is this really necessary in the sense of programming? I mean, can we do without it? Yes. But this, to abstract this out, basically you don't have to implement the same functionality 3 times. You only need to implement 1 time, and it can be shared by all these things, right? So that's just making your design better. But this is not determining whether you have correct design or incorrect design with respect to functionality. if I actually implement this functionality 3 times correctly, I'm doing 3 times more work. I'm implementing the same functionality. If I have a slightly better design, share this printing function, I only need to implement print function once, you realize the same functionality. My coding efficiency is better, right? So my code structure is better because why you want this? Because you want to be able to have one way of printing, and if the printing is wrong, you can go to that function and see why. If you implement this 3 times, okay? If something wrong, you have to go fix 3 times. That's why you want functions, right? That is why we have functions to begin with. The first programming language I learned, called Fortran, don't support this. There's no definition of function. Okay, we essentially have to simulate functions by using goTos. So basically we have, our program is look like this. It really look like this. Okay, this is it's just the name of the program. Okay? Then we have a blob. Then we have a blob. Then we have a blob. There's really no relationship, sequential relationship among these blobs. Okay? The code transition doesn't go like this. Okay? This is what you probably expect if you have a sequential code. You would say, okay, this block go to that block and so forth. Okay, what we had, because we have no function, essentially the way we implement this is always say goTo. The last thing is always a goTo. Okay, this is 1, this is 2, this can actually be say go to 2, this actually can say go to 1. So essentially, even if this is sequential, our program actually execute this way. All right? Then we have goTo out of there as well. So essentially, you have to simulate, but without that compiler support, you're making mistakes all the time.